All right, so here's the homework video for 3.4. As I would have mentioned in class, please write equations in slope-intercept form. The book kept asking for them in standard and or general form, which really just isn't that useful. So for 25 through 28, they give us points and ask us to find our equation of our line. Now in 25, some people might notice just from the 2 points given that they've got a vertical line, and any vertical line is always x equals the x coordinate, but if you don't notice, that's okay. What should give it away is that when I set up my slope, I get 0 in the denominator. If I end up with 0 in the denominator, again, I know I've got a vertical line. Well, what's the equation of that vertical line? X equals the given x coordinate. 28 is what we're going to see most often, where I can find my slope, and by the time I find my slope, I know that I've got -3/2. Now you can choose which point you want to use to set up your point slope form. You could have used this point. I went with the second point, but at that point, I took care of my double negative. I distributed my -3/2, added my 5/2, got my common denominator, and once y is isolated, I've got my equation. I would know my slope is -3/2. I would know my y-intercept is 7/4. Oh, I apologize. These are out of order. 27. In 27, some people might notice right away from the y-coordinates that this is a horizontal line because the y-coordinates agree. And we know the equation of any horizontal line is always y equals the y-coordinate. Unlike vertical lines, if we think of these as kind of opposite values, now my 0 is in the numerator, and that should tell me it's a horizontal line. So my equation is y equals 1/2. Back to 26. Again, I apologize for these being out of order. I find my slope. I chose to use the point 1, -4. You could have used the point 4, -5. I set up my point slope form. Y minus my y-coordinate equals my slope, x minus my x-coordinate. Distribute my -1/3, subtract 4, which is the equivalent of subtracting 12/3, and I now have my equation. In 35, they asked us to find the equations of the lines that are parallel and perpendicular to this given line and run through the given point. So the first thing I need to do is find out the slope that I'm comparing to. So I subtract x, I divide by 2, and I now know that the slope I'm focusing on is -1/2. If the lines are parallel, I know that slopes are equal, and so you'll notice I just use the exact same slope and the point I was given. For perpendicular, I need to use the opposite reciprocal. So we know perpendicular lines have opposite reciprocal slopes, and the opposite reciprocal of -1/2 would be 2. Substitute in the same point, and in each case, I've asked you to write these in slope-intercept form. 36 follows the same pattern, so I start isolating my y value to find the slope that I'm going to focus on is 1/3. When lines are parallel, those slopes are equal. I took care of my double negative, distributed my 1/3, added 2, which is the equivalent of adding 6/3, and I've got my parallel line. And then I use my opposite reciprocal, so -3, for my perpendicular line. And then I follow through that same work. Distribute my -3, add my 2, and I've got my perpendicular line. 39 asks us to find the equation of the line that goes through 1, 4, -3, 4. Again, some people might already notice that they've got a horizontal line. But if we don't, we find our slope, we have 0 in our numerator, and 0 in our numerator tells us we've got the horizontal line y equals 4. 46 tells us that we've got the x-intercept of -3 and the y-intercept of -1, which means I can set up my ordered pairs -3, 0, 0, -1, use those 2 points to find my slope. Now for some people, they're going to know right away that since we're given our y-intercept, we could immediately have just written our equation in slope-intercept form because they told us the y-intercept and then we found our slope. But if we take the time to set up our point slope form, we're going to end up at that exact same equation anyways. 47 wants us to find the line that goes through the point negative 2, 1, but is parallel to the line that goes through 1, 4, 2, negative 3. So if I know these lines are parallel, they're going to have the same slope. So I find the slope between the 2 points given, it's negative 1, and then I use negative 1 and the point that I'm working with, negative 2, 1, to set up my point slope equation and isolate y. Similar in 48, we're going to go through the point Q, but be parallel to the line that goes through the other 2 points. So I find the slope between those 2 points, combine the slope I just found with the points I've been given, isolate y, and I now have my value in slope-intercept form. All right, hopefully this helps a little bit with the homework. Again, if you have any questions, please feel free to ask. And again, like I said at the beginning, all of these are in slope-intercept form. That's the form I asked you to write it in because it's a much more useful form.